Okay, and there's a lot of vocabulary in here, and you may be familiar with it. You may not want to be particular about it, but you've got to be particular. The thing about this class is you're going to learn how to reason. You're going to learn a lot of things about geometry and relationships with lines and points and angles and shapes. You're going to learn a lot about that. You're going to say, where am I ever going to use that? You're right, you may not use it. But what you will use is a logical reasoning. Knowing you have something and drawing a conclusion. So hopefully by the end of the year, you will have enough logical reasoning that you can talk your parents into the car keys for the car. So you can go out and drive around. Just be careful. I wouldn't want to learn how to drive today. There's twice as many people as there were when I was driving. It's crazy out there. Okay, so point is that you can actually learn to reason logically. If you want to become a lawyer, this course is critical to thinking logically. So your goals. By the end of this lesson, you will be able to describe, draw, a lot of drawing in this class, and provide proper notation. And I mean, I'm going to be picky about it. For points, line segments, lines, rays, planes, angles, collinear points, and coplanar points. Recognize and label congruent line segments. That's our main goal today, but we got to get some vocabulary here. So now is where you guys have to do a little bit of work. First thing is we have defined terms and we have undefined terms. Well, to define anything, I have to have some words I already kind of know what they mean. And you can't use circular reasoning. You can't use one word to define something else. So we have these undefined terms. They're kind of our building blocks. They're things that I can talk about, but I can't really define them for you. And they're descriptions. 3 words in geometry that are formally defined, not defined. Point is the first one. So that's our first one on our little yellow sheet. Okay, so I've got the first 3 right there. And then we're going to describe what a point is. Point is the most basic building block of geometry. It has no shape, size, only location. So if I want to put a point on here, there it is. Now, my point has thickness and width. I'm not going to argue. You're right. It does, because I can't represent a point without drawing thickness there. I mean, I can make a bigger point like that, but honestly, points don't have any size to them. This point is no bigger than that point. I just drew it bigger. It's just so you could see it. It's the only reason. Okay, so we just draw these little dots for our points, and it just references the location. This location is different than the first location, and we just call it point P. There. That's it. It's called point, usually by a capital letter, not usually a lowercase letter. Okay? I can't really define it, but I can describe it. It has no shape, no size, just location. We represent it by a dot. Is that okay? So I gave you space on your sheet to write a description and then draw a picture of a point. So a dot, and I would label it with a P. You can call it A if you want, doesn't matter. Okay. Next word is a line, and we're all familiar with lines. The thing is, lines are always straight. So you might just try to describe something saying that's straight line. You don't have to use the word straight line. Lines are straight. They're straight. They're continuous arrangement of many points. So this is not a line. Those are 2 points. But if I want a line, I got to put a whole bunch of points. Actually, an infinite number of points, and my line's not exactly straight, but it's supposed to be. Lines go forever. Yeah, if you can't see, help me out there. They have no thickness to them. Mine does have thickness. I can do this line like that, or I can do this line. The second one's thinner. It doesn't matter. It's just representing that continuous arrangement of points. So there are lines in this room, where these planes meet. There are lines there. You kind of see them. They're all different thicknesses. Just a continuous arrangement of many points. In fact, so many points, if I pick this point here and this point here, guess what? I can find another one in between them. And if I take these 2 points, this one here and this one, can I find another one in between there? Yep. I can keep going. The points are separate, but they're connected. It's kind of weird. So it's an infinite number of points. In between any 2 points, you can give me another one. Well, lines we always assume to be straight. Okay, here's the important part. How do we name a line? Because we have to be able to communicate. You have to tell me what you're talking about. There's 30-some in here. There's 32 in my other class, 33 actually. We got to communicate. And when you take the MCA test, there'll be a lot of geometry. And I'm doing some ACT prep with a student. Lots of geometry. I'm glad I'm doing it because it's going to help me to say, hey, this is on the ACT. Things I was not aware of. So you find any 2 points on the line. Now I'm going to put another point in here. There's C. It's a little smaller than A and B, but who cares? There is no size. We make them bigger so we can see them. Now you know where I'm talking about, A and B. And we name that line by using the 2 points, and then we draw a line above them. We must put in the arrows. Not enough to draw a little line above there without the arrows. You must put in the arrows because that means it goes forever. An order in which you name the points is not important. So if I want to start with B and then go to A, that's fine too. There it is. That's 2 ways to write the name of that line. There are other ways, but that's enough for today. Okay? Any 2 points. Any 2 points will give you a line. Don't forget the little arrows on the top because that's important because it's wrong if you don't do that. Ready? A plane. Anybody do wood chop? Plane things off? I can't believe there's nobody here who's done that. Yeah, thank you. Because I'm saying I've done it. These are planes, and that's like a written P rather than can't think of the words. But I don't care. You can just call it plain P. There is no thickness. There is no width. And actually, I could draw this a little bit better. And that goes forever, and that goes forever. And your tabletop, there's a plane that contains this tabletop. Now, this tabletop is finite. It does have length and width. But the plane that this is on goes forever. Now, it's kind of weird. Now, we're not going to do too much with planes. It has infinite length and infinite width and no thickness. Extends infinitely. I don't like the fact that it says length and width. It's infinite. And here's an example of an airplane landing on a plane. And like if you ever make cookies, you roll out your cookie dough. Yeah, it's a nice flat plane. Now the geometry we're going to be doing is assuming we all live on a flat plane, but do we? We live on the Earth. Is the surface of the Earth flat? No, it's curved. Even in the best case scenario, even when you're in the desert, there's curvature. That's why you can't see forever. So, but we are going to make the assumption that everything we're doing here flies in a plane. Okay? That makes a lot of things easier. Now, next part on your little yellow sheet is definition. And a definition is a statement that clarifies or explains the meaning of a word. You can't ask why. I'm not sure how you spell it. But dogs in Arabic are kelb. Cats are ota. Oh, my favorite word in Arabic is no. I don't know if anybody knows, but the word for no in Arabic is la. See, when the dogs are bad because they're always naughty because they're dogs, you go la 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 la, just like your parents are saying no 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 no. Same thing. So dogs have now learned a little Arabic, and sometimes I have to speak in Arabic because if you can't say we're going to go for a car ride, because they get all excited because they know what it is. Or treat? No, can't say that either. They know what that is. Anybody have animals, pets? Do they know what the word treat means? Yes, they do. But you learn it in different language. Sometimes I speak to them in French, and then they don't know, which is good. Okay, so it's a definition. Why did they call a dog a kelp? Why do we call that a table? In French, le table. What is this in Spanish? Mesa. Yeah. I don't know what is in Arabic. I should. My Arabic's not that good. I probably know 30 words. Okay. So you can't ask why. Why did they call it collinear? Well, this kind of makes sense because collinear means you lie on the same line. Co-workers. We all work together. Cooperate. So collinear means points on the same line. So if I put another point here, D is not collinear with A, B, and C. It is collinear with each of those points separately, but I don't even want to go there. D does not lie on that particular line. So A, B, and C are collinear. And I remember the first time I ever introduced the word, it seemed like, oh, this is kind of obvious. I found out, no, it's not so obvious. They just mean they're all on the same line. So if they tell you that you have points that are collinear, you better be able to draw a drawing like that, because that's what's going to happen. And you're going to see it even in the first night's homework. Where coplanar means the points all lie in the same plane. I'm not sure I understand this diagram. I didn't do that. Tennis court is, everything in the tennis court is coplanar. But I don't know if those guys are on the same plane, really. So they're on the same plane. Yeah, I'm still with you, Sam. You could have another point out here. This point right here, this imaginary point here. That's not coplanar with D, E, and F. They don't lie in the plane. You ever sit in a chair that rocks back and forth? I hate those. Well, all it takes is 3 points to get a plane. So if you went to the state fair, or you saw how they milk cows, or if you go into somebody's barn and you're milking a cow, if you ever notice, the chairs only have 3 legs, because 3 legs give you a plane. You always get a plane, but you only get one. If I introduce a 4th point, and it's off here a little bit, then you rock between the 2 planes. That's the problem. So now you have an explanation using geometry why that chair wobbles. And you probably never thought of that before. I didn't until I taught geometry. You get more than one plane. That's the problem. You want only one plane. But when you do 4 legs, and you get all 4 legs where the bottoms all sit in the same plane, then things are a lot more stable. You can fall off a 3-legged chair pretty easily. It tips over. Okay. Not to say we're going to do too much with this, but I might give you a picture without a picture and say, hey, these points are on the same plane. They're coplanar. You need to know what it means. Now, this is important. Line segments. I think we are on the back side. Yeah. Okay. Line segments consist of 2 points. These guys are finite. They don't go forever. It's part of a line. I like to write that, part of a line. And they have these points that are at the ends of the line segment, and those are called endpoints. There's an endpoint, and there's an endpoint. Okay, what's going to be important here? How we name it. So we're going to name it by the 2 endpoints and draw a little segment. Not a line with the little arrows, not that, just a segment above there. If you want to talk about the line AB, then I would put the little arrows in, and that means it's the line containing that segment, which would go forever, which of course it doesn't, because we're talking about just the segment. Now, important things about vocabulary here. When I have AB with just the segment above it, it's referring to the segment. If I write AB without that little segment symbol, it's talking about the length of AB. You can measure it. Pay attention to detail. It's true. So this segment is named AB. And the length of that segment is AB without that little bar above there, which is equal to 5 centimeters. And yes, we're going to be a little bit picky about units. If you've ever built anything, you have to worry about the units. Always. Yes. Nope. And you can also call it BA. Okay, so without the little segment up there, it means the length of this. When I have the segment there, you're talking about the object. That's the way to say it. The object. AB. Okay, it's not talking about its length. It's just talking about the object itself. Yeah, that's going to be new for you. You've never had to be picky about those things before, I don't think. Or if you have, it's been a long time. Now we have the word congruent. Have you seen that word before? Congruent looks like this little symbol. It's an equals, and I think this is called a tilde, which means if you have congruent segments, they have the same length. So if I were to measure AB and measure CD, they would have the same measurement. Whoops. And there we go. And we say that AB is congruent to CD, or if they're congruent, they have the same length. And if I want to talk about the length of AB, it's AB without that little segment equals CD. So congruent is a little bit stronger. It's got this little extra tilde up there, which is what it's called. And we may give you information like this, saying AB is congruent to CD, which means if I were to measure them, they have the same length. I don't care what the units are. They have the same length. Is that okay about congruent segments? 3 more words. Big words, though. So we've got point, and we've got line, and we've got plane, and we've got segments, lengths of segments, and now we have a midpoint. Did I miss it? Oh, I guess we're going to put this here. Here, these segments have the same length. So what goes where? I have an equals and a congruent. What goes between the MA with the bar and the TH in the bar? What goes with the MA without the bar and the TH without the bar? What goes in this one? Yep, the congruent segment. And then this one goes here. Is that okay? Seems picky, but it's not going to be that picky. Midpoint. No, we're talking about midpoints all the time. And you should have done midpoints in algebra, but I'm not sure that you did. A midpoint is a point on a segment that is the same distance from the endpoints, so that the distance between T and U equals the distance between U and V. And I'm going to do one more than they did in this slide. If I want to say that that's a midpoint, then these two segments are congruent. So I'm going to mark this with a little mark here, saying that matches up to this. So can you name those segments? What's the name of the first segment? Don't be shy. TN. U. What do I need above that? A segment. It is congruent to what segment? UV. Some of you, this is going to be like, this is easy. And some of you are going to go, oh, who cares about that stuff? Well, we care because it's communication. So if those two are congruent, then how can I write in the statement of equality what lengths are equal? The distance from T to U equals the distance from U to V. You might say, I'm going to meet you halfway from one end of the mega mall to halfway to the other end of the mega mall, which puts you probably on the Snoopy ride, the roller coaster ride someplace. Who knows? No, I've been there for a while. Okay? So that's midpoint. Divides the segment into two equal segments. Array. Well, I like to talk about a ray of sunshine, don't you? And rays have a beginning point, but no end point. They go off forever. So that's the sun rays. I'm going to go out and catch some rays. The rays start at the sun, but go forever. They could start like this. And when I put rays together, I form angles. When we write the name of a ray, we always start with the end point, not the one where it's going on forever. So the end point here is at A, right? So this is A, and then we find another point on our ray, which is B, and then you draw a picture of a ray above that. Naming that BA is wrong because it doesn't start at B. This is where you start. I know it's an endpoint, but it's where you start. So this is the same name. This is also AB. Even though B is to the left of it, it doesn't matter. This tells me I'm going to start at A. And there's ray AB. It's all the same. And then we finish with a little arrow here. And you can name this a lot of names. You can name this BA, which is written there. Or you can name it BC, because we're starting at B. But the B has to be what's first. Just pointing out so you notice that. B is where you begin. The endpoint's where you begin. You might want to have a picture of that, but that's up to you. Okay. One last word, bisect. A midpoint bisects a line segment. You guys ride bicycles? How many wheels? Two. Cut into two equal pieces. Two equal. I want to say pieces because we can talk about bisecting angles as well. So if it bisects this, then this segment equals length of that equals that segment. I use these little tick marks and saying those guys match up. They are congruent. Well, it's the same as a midpoint. It's no different, really. Now, bisecting an angle is trickier. Now, how do we name an angle? An angle is made up of rays. I'm going to draw this the same as what I have written there. There's B and there's A. That's ray BA. And I'm going to draw this ray down here, call that D. How do you name that one? BD. Okay, now I want to bisect that angle, so I'm going to draw a ray here in the middle that divides these angles into equal angles. Angles of equal measure. So if this big angle is 60 degrees, how many degrees in each of these little ones? 30. We will talk about naming angles later. I guess it's not for today. Kind of seemed to fit to me. So where's my piece of paper? So I took this piece of paper, and that's a 90-degree angle. And in second grade, my daughter was learning about 90-degree angles. She thought they were kind of hot. 90 degrees, hot angles. She didn't know angle measure. And why is it degrees? Why are there 360 degrees in a circle? Because somebody said so, the Greeks. So in pre-calc, we're going to change all that. So I can bisect this angle by folding along here. And you can see that these two angles are equal. And if this is 90, how big are each of those angles? 45. And that's the type of math you're going to need. So if you want a calculator for that, that's fine. I don't have any problems with that. I want you to get the geometry. It's not the arithmetic that I care about. Okay, there we go. I'm going to give you a packet because we don't have our iPads yet. So you get a packet, and we're going to do LR1 Lesson 1. It is going to assume you know how to graph points. I didn't review it. So it's it's the first page, front and back, and then it's the front page of the next one. You stop when you get to LR2. The assignment, well, okay, we talked about horizontal. I'll just do them all. R2s, when you get into the grading and stuff, R2s are easier than R3s. And we aren't going to talk about that today, but you're going to be graded by how many R2s you get right, how many R3s you get right, and it's going to be right or wrong. However, without any supporting work, it's wrong. So you're going to do front page, front and back. And there are a lot of ways to name number one. Yeah, I'm going to ask you guys to put your backpacks under your tables. Oh, there you go. Because I want to be able to walk around and help. And you and I together will get used to the naming these. Right here.
How about like writing better?
No, right here. Yes, you will, but we're going to be working on iPads. But I may make a finite number of copies. Oh, wait, they're always finite. A small number of copies. So you're going to do the first side, the second side, and then like it says, the R3s, to give you an idea how hard the tests are going to be, it'll be like 9 and 10. And there are many answers to question 17. Oh, we do protractors. Well, fun. So on the first one, let's kind of do that together. Now, answers are posted up on Schoology. Oh, I don't know if I have them up there yet. I've got things to get done, but they will be. So yeah, you could copy them. Doesn't do you any good. If you don't know how to do it, you're not going to pass the test. Okay, name the line in two different ways. There's many ways to name this line. Somebody want to give me one way? Yes. AR, and what should I put above it? A line with the arrows. Don't forget the arrows. Lindsay, can you give me another way? Since I know you. Take any two letters. I don't care. T and what? TR. And then put what above it? Little arrows. Little line with arrows. There's more. Could you have RA? Yeah. More. RT. There's two more ways. AT. And what else? TA. I think I got them all. We'll talk about counting problems. You're not going to like those. Okay? So that's the problem. You only had to name two. You don't have to have them all, but you might want to put them all. It's not a big deal. Yes? No, always two letters. Good question. Excellent question. Always two letters. You can sometimes name it ART, but it's not the norm. We get into arcs with those. Uh, Probably not. I have rulers. Sometimes a straight edge, but I actually have rulers. But please, please return them. You can share a little bit. This is real time, so I'm trying to stop this so it's bedtime.